You bet. Thanks a lot, Peggy. I would also say that I am a Scott Kuykendall groupie as well. Is that that's the name, a groupie, right? Yeah, yeah. Yeah, Scott and I have known each other for a long, long time. We are awesome advocates for each other. He's been such an advocate for what we do, and so I can't thank him enough. And I'll start following him around someday. I don't know. So yeah, I'm a geologist down at the State Survey. I work with Trent um, at a sister organization, the Geological Survey. We're all part of this big research organization at U of I. And I would also encourage, just like Peggy had said, if you ever get a chance to see Trent talk more, I don't know if he has a social media presence or whatever, but if he's giving presentations, try to listen. He's a fantastic speaker, fantastic communicator, and I've always enjoyed listening to him as our state climatologist and a great resource for the state. Um, so I wanted to talk today, similar to what we did 2 years ago in Boone. I was going to kind of I did a review of the soils and geologic history of Boone County. We're going to do that today for DeKalb County, which also includes Boone County. Uh, I'm a glacial geologist. I study the ice age history of North America, and specifically, my career is driven towards Northeast Illinois. But I wanted to kind of review what I'll be talking about, the basics of soils. Now, I just found out it seems there's about 4 soil scientists in this room. Bear with me, please, and help me out if you get a chance. But I just want to review how, you know, the basics of soils, and then how geologists, from a geologic standpoint, how we use those soils and the soil information. It's fantastic. So, and then go through the glacial history of Illinois in general, real quick, and then geology of DeKalb County, more so the landscapes and the glacial history of DeKalb County, and then kind of the progress we've been making in Boone County as well. Basic question: what is a soil? From a geologist standpoint, this is the unconsolidated dirt and materials at land surface that are interacting with the atmosphere and water that had some kind of a parent material that was geologic in origin, and then that parent material has been altered due to these processes at the land surface. I think that's a pretty good definition. And there are different components of soils, of course. Mineral matter is what we study a lot of, but then there's the chemical and biological processes that are critical for forming soils in general. And through those processes of chemical and biological and the junction of those with the physical, sets up these horizons within a soil horizon. The A horizon is that organic, rich, kind of active organic zone, and then underneath that is oftentimes an E horizon where stuff has been leached out through percolation of water, leaches out carbonates, for example, and clays. And then underneath that is a B horizon, we often call, that is the accumulation of clays that have moved down through the soil horizon. And those B horizons are, oftentimes we see B horizons in paleosols. As a geologist, we see buried soils that are 100 feet down, and we drill through B horizons that are still there. And so we use these paleosols as markers in geologic history. And then the C horizon is just almost getting to the parent material, and then you get to the parent material itself. That parent material can be sand, rock, clay, something like that. In a ball of soil, you may have mineral matter, water, air, organic matter in different proportions. Of course, those proportions can vary. Worlds without soil, of course, places that at least we visited is the moon. Robots have visited the Martian surface, but of course those are environments where you have the mineral matter, but you don't have the water, you don't have the biology to make it a soil. to try to understand conceptually what's going on. Of course, soil is just as important as drinking water, for example. It sustains all life. I mean, it's pretty simple. Plant growth, organisms, building buildings, understanding the strength properties of buildings is another thing that I've studied, is soil strength properties. Not necessarily, well, yeah, part of all of that system. Um, Filtering rainwater, of course, what we've talked about before is infiltration rates, and different types of soils are going to have different controls on infiltration rates. From a geologist standpoint, uh, water infiltrates through the soil, it picks up carbon out of that soil and then gets down into an aquifer. And oftentimes, if we understand the situation, we can take a sample of that water and date how old that carbon is in that water sample that may be 300 feet down through C14 dating. Uh, so soils have a huge importance throughout the whole water cycle system, as far as I'm concerned. Uh, yeah. Okay. Sorry. Sure. Oh, I can speak up to. I would. That's my assumption. Yeah, they have the mineral matter that we know the minerals. There are beaches on Mars that are made of a mineral called apatite, which is green, like pure green sand. It's amazing. I was talking to people that were on the Mars rovers missions, not to Mars, but on those missions, and yeah, they have these green beaches that are made of apatite. It's amazing. But yeah, there's no water and there's no organisms to create a soil out of that mineral matter. So we know the minerals on Mars, but we just don't have everything else. Feel free to interrupt me again at any time. I'm happy with that, and do this if I need to speak up more. So soil scientists have classified soil varieties around the world. In general, there's like 12 of them. A lot of them, when I look at maps of soils around the world, it seems like they are oftentimes controlled by latitude, right? So there's equatorial soils that are very similar, and then those soils propagate and have patterns that are controlled by latitude, but also controlled by mountain ranges and different climatic effects and vegetation effects that are a function of latitude, for example. So different types of soils around the world. We have soils in the Midwest and even in DeKalb and Boone counties, alpha soils. These are just your typical soils of grassland type environments. There's deep tropical forest soils. These are soils or non-soils, very young soils in dune fields over in western Illinois. Youthful soils out in the mountain ranges in Colorado. Other soils, mollisols, are the prairie grass soils from Illinois and the Midwest. Again, desert soils, all kinds of different types of soils that are all, again, a function of that that triplet of mineral organisms and the other one. So not only are these soils a function of latitude and all that, but they vary by ecology and climatic region, as I mentioned before. Again, these are temperate deciduous soils are common in Illinois and Midwest, for example. Coniferous forest soils, northern Minnesota, potentially, Canada. Grassland soils, Kansas. Desert soils, Arizona. Tropical soils, maybe Florida. So definitely regional. A lot of the soil type information that we use is oftentimes dependent on just topography, slopes. So even within a region, you can get many different types of soils just based on slope and material. So that controls water. basically water infiltration and and uh, and the proximity and the time constraints of water in a soil environment. So on tops of slopes, you can often have some well-drained soils that are nice and dry. You can put a nice little house up there. And then in the lowlands, of course, you have wetlands, and where not only surface water is draining down to those wetlands and keeping it very mucky and organic, but also groundwaters can oftentimes seep into those mucky lowlands. So even in the context of top of a hill, bottom of a hill, you can have dramatic soil changes at a local scale. And this will all come back into, I'm going to show some of those slope changes in the context of geology here in a few minutes. So I mentioned before the agronomists and soil scientists have kind of developed 12 orders of soil taxonomy globally. In Illinois, we have two primary types of soils that are at least regionally more extensive, is the mollisols and the alpha sols, as I mentioned before. Mollisols are these former prairie grass soils that are very organic rich. And you can see that that's the darker colors, the darker reds in Illinois. And then the lighter oranges are what we call alpha sols, which are more drained, more leached, and create a different soil type. A lot of those are in southern Illinois, where you don't have the fresh lusk cover of the last glaciation, which we're going to get into very soon. Again, just look at northern Illinois. This is a newer map that I found from the state agronomists. What is his name? From the USDA state office. I don't know. Anyway, I've met him before. But this is a newer map that I didn't know existed that has pretty high resolution soils data on it. And so DeKalb County here, again, alpha sols are the orangey stuff that's in the South Branch Kish, and then all in the uplands and even some of the lowlands, you got these mollisols, which are organic rich. So we use a lot of these data in geology as well. So I pulled the soil survey data off the website of DeKalb County, and this is a little area zoomed into northwest DeKalb County in the South Branch. And of course, these soil scientists, they know what they're doing. These folks are fantastic to set up the base of what we do as geologists. We can't really do what we do without them. I mean, we can, but it's a lot harder. So these soil scientists do these detailed maps based on aerial photography, slopes, and they go out and they do some sampling, gridded sampling across the county. It's fantastic work. And then they use these aerial photos to map out these polygons. And then with each of those polygons, they have descriptions of what it is. And they name these soils, the Dana Brook soil or the Clare Silt loam soil. But within that, these soil scientists always put what kind of landform it's part of and what the parent material is. That's the stuff I look for. The parent material is telling me what the geology is. Landform is the geomorphology of the landscape that was formed by geologic processes. And those are always part of these descriptions, along with thicknesses and all that kind of stuff in centimeters and drainage patterns and all that stuff. So I'm always looking for geology, and we can dig deeper into the data in these hard copy forms. Maybe it's in there somewhere, but in the digital forms, we can dig in. And one thing that I always do is if I go into an area to map what the geology is, I dig into those polygons and I can pull out the lowermost soil texture that's been described or estimated for that soil. That texture will be something like what's called a loam. Now that's pretty generic in this upper Dana Brook soil. But in this lower one here, the Clare, the lowermost texture is stratified sandy loam and gravelly loam and silt loam. Like when I see the word gravelly, that sparks a trigger in me. And when I see gravelly and I see the landscape and they say that's part of an outwash plain and stream terrace in the landform, and the parent material is either loess or the underlying outwash. I know geologically, the soil scientists already figured it out, that that's part of an old stream bed that was glacial outwash. This is an old stream bed that is abandoned. And the active stream bed is where the river is now, but this is an old stream bed that's a terrace that's left at a higher elevation from an older time when the glacier was nearby. So we can extract all this geologic information out of the soils data. And when I start mapping colors and I assign different colors to different textures, I see different, what we call facies, like different patterns of texture changes within the geologic materials. So these terraces, these pink colors, are places where I know that the material is more gravelly. Anything I see that's gravelly is going to be a red pink color. Anything finer grained is going to be like yellow and orange. And then clays, I always map those as blue and green. So the geology starts piecing itself together of where different materials are at the land surface just by color coding different things. So I use this kind of stuff as a guide when I do geologic mapping at land surface and then trying to interpret the subsurface as well. Long story short, we love the soil scientists. So yeah, this is a screenshot of kind of northern DeKalb County with these soil textures mapped as a guide for understanding geology. And we can start to see then, you see the shaded relief on this. This is the south branch of the Kish. You see the sand and the gravels in the Kish Valley itself. We see terraces that are gravelly terraces that are higher in elevation, that are in the valley itself. The sandy stuff is down in the valley because it's more active and younger. And then these gravelly slopes here on the upland slopes, I don't know why they've been described as gravelly. So that might be an indication that there was an ice front right there and gravel was coming right off that ice front. It's close to the ice front. That's a hypothesis. I have to test it. But anyway, these maps of soil textures are beautiful to try to interpret details of geology. Can everybody hear me okay? Okay, great. Thank you. So we can go from straight soil classifications. This is on the left is a map of, is my mouse showing? Oh, my mouse isn't showing on the screen. Oh, shoot. That's okay. On the left is the soil classifications of all the different names. So the Clare and all the different soil names that soil scientists love to use. And then I take those textures out of those names, lump them together, and we start to see in the middle different patterns of textures related to geology. And then on the right is an actual geologic map of different geologic units based on those textures. And we'll get into that geology in a second. So it all relates to one another, and it all starts with soils. I don't think I've really said that before, but it does. So that's a brief review of soils and soils in DeKalb and the value of those. And then we're going to relate that back to Ice Age geology in Illinois and geologic history of DeKalb and Northeast Illinois. In Illinois, we have good record of the last two ice ages, and we have other records in the subsurface of older ice ages. But the two that are expressed at land surface, one's called the Illinois episode. That's called the Illinois episode throughout the world because that everywhere you see in pink is where glaciers in Illinois made it from Canada and came down. We'll see a map of that in a second. But down near Carbondale, the southernmost point of that pink is the southernmost point in the northern hemisphere, all the way around the hemisphere, even in Europe and Siberia and Russia, where that area was all glaciated. That's the southernmost point in the northern hemisphere that we ever know that ice made it in the history of the last 2.5 million years. So that's a pride and joy of Carbondale in Illinois. That was about between 180 and 130,000 years ago was this kind of ice age. That was the Illinois episode. And then we had 100,000 years of no ice age, no big ice sheets in North America or Asia. That's the interglacial. And then the last glaciation was about 24 to 28,000 years ago. We call that the Wisconsin episode. And the extent of the Wisconsin didn't get as far south as the Illinoisan. Got down to the southern tip of it, was down near Mattoon, Illinois, westward in northern Illinois, westward to Marengo, basically, Marengo and Harvard, and then out to Peoria and out to Princeton area. So anywhere you see the green tints, that's the extent of the last ice age in Illinois. This is a map of North America during one of those last ice ages, where there is no Canada. Canada is gone. It's covered in an ice sheet. There are multiple ice domes. There was a Cordilleran ice sheet over on the coast in the mountains, a bigger dome called the Laurentide ice sheet that covered Canada. And we're just at the very, very southern edge, the southern tip of where all these ice sheets were ending. And that's the value of being in the upper Midwest. We have about 16 scientists at the survey who are quaternary scientists, glacial scientists. That's the same with Indiana, same with Ohio, the state surveys. Because the glacial record and the glacial resources of all those states in the upper Midwest are all a function of being at the very tip and the edge of where the glaciers were moving all this material down and dumping it in the upper Midwest. And that's the source of so much of our sand and gravel resources, our aquifer resources, water, etc. The colored chart here in the middle is a time diagram of Earth. So from top to bottom, it's about 4.6 billion years old. In glacial time, the most recent glacial time is just the last 2.5 million years. And if we have time, we'll talk about why that is. But on the right is a record of what glacial events we have records of in Illinois. So the upper blob called the Michigan sub-episode, that upper blob of blue stuff, those are little fluctuations of ice sheets in the last 24 to 28,000 years. Below that is the Illinois episode. That's the 180 to 130,000 year old episode. That's an episode that influenced both times in DeKalb County. And then we have older episodes that are all buried in the subsurface. We don't really have surface expression of the older episodes, but we know that they happened in Illinois. Overall, in the last 2.5 million years globally, we've had 25 ice ages, about every 100,000 years. That's another discussion. Hopefully we'll have time for. So we have record of about at least 2, if not 3. The images on the right, if you imagine what DeKalb County looked like and what Boone and Marengo looked like, McHenry counties, this is what it looked like. If you were to live back there, you could walk right up one of these glaciers. They're low sloping. They're not walls of ice. They're dirty. You look at it, it almost looks just like a dirt hill. But out in front of these ice sheets, we do have these large braided systems of sand and gravel that were being deposited in the river valleys that we see today. So to look at northern Illinois, again, think of it in the pink and the green. The pink is the old stuff from the last glaciation, penultimate. The green stuff is the most recent glaciation. And we'll go through a little timestamp of where ice sheets were at different times. So long before 135,000 years ago, can I just ask, do we need to be out by 1:30? We got a late start. I guess, yeah, that's sorry. I'll move fast. So Illinois, again, imagine this and imagine like 140,000 years ago, ice was all the way across Illinois, all the way to southern Illinois and Carbondale. That ice then started to retreat, and we have all the landforms of southern Illinois that we map associated with that. And the yellow band is where we are in geologic time with the little blue blobs of ice advance. And then sometime less than 135, that ice was retreating in northern Illinois, and it kind of stopped right there on the east side of the Rock River and created these beautiful lineations up in Boone County. It's the origins of the Rock River as we see today. So the Rock River itself is about 136,200 years old, the best we can guess, plus or minus a couple thousand, I'd say. Uh, we have back about 10 years ago, some scientists that I work with came up into this area in Boone County and Winnebago County, and they were dating sands. They could take sand out of the side of a quarry, and kind of like the old cameras where you cover yourself in a dark area and you take the sand out, you don't let the sun get exposed to it, and you take it out, you put it in a black container, and we can take that into a lab and understand, measure when the last time the sun hit that sand. Because when cosmic particles hit a sand grain that's like a certain mineral, it will change those minerals in that sand grain, and we can measure the last time it was exposed to the sun. So we know it's right around 136,000 years is the age of the Rock River. So when ice was here, we know that, okay, where does the meltwater go? It was coming down the rock and then going to the west of the rock. It was trying to come down this Green River. We call it the Green River lowland down there. So then this ice went away for 100,000 years. We had a landscape that was out there, and then the ice came back 24,000 years ago-ish. And it only came back to Marengo. See Marengo Ridge. And I came across, this is called the Providence Moraine, we call it. So moraine is the ridge that formed at the edge of this ice sheet, and that ice sheet sat there and built this ridge out in front of it like a conveyor belt. So then what I like to do is to try to understand, okay, well then where does all that meltwater gotta go? This is a warm glacier, it's the warm temperate environment, it's not like frozen. But so this discharge water has to come from the north. It was coming down the rock. From the east, it was coming down the Piscasaw, the Kish, the south branch of the Kish. You guys see where I'm pointing? South branch of the Kish is right there in northern DeKalb. I don't know the name of that stream, but then, so you can see where these ice sheets and margins were based on where modern rivers are, because they were the drainage pathways for these ice sheets. A few thousand or 1,000 years later, that ice backed off and actually re-advanced again. And then that meltwater reoccupied those rivers again, and reoccupied trying to move through the middle part of DeKalb County and move to the north, because it had to go through that rock valley. It couldn't go down to the south. Maybe a little bit of it was poking over into the Green River lowland. I'm just going to call it that. Does anybody know the name of this little valley down here, or the stream down there? That's okay. And then about 3,000 years later, again, these are, if you look at that blue blob diagram, these are little advances and retreats and advances and retreats. So this thing advanced one more time about 21,000 years ago and got over to the Fox River. And as we, in southern Kane County and on the east edge of Kane, once that Fox River opened up as a drainage, it abandoned all the drainage in the rock and through the Kish. And so any glacial drainage ended up to the northwest, and it all started going down through the Fox and the Illinois Valley about 21,000 years ago. And then by 16,500 years ago, we had no ice in Illinois and haven't had since. So that's your quick summary of Northeast Illinois geology. Yes.
I understood that the Kish, often supposed to say, why is it from north?
Oh, sure.
And did it reverse its direction at some point? Are you aware? Can you help explain some of that?
Oh, the southern Kish? Why the south branch flows north? South branch flows north because it can't get around a moraine. There's a moraine. Oh my gosh, I wish I had a pen. Oh, I'll go to. So this is an upland that was here 135,000 years ago. This is an old ice margin. That it can't get across this. The ice margin was here, with the Wisconsin, and so meltwater had to go this way. It had to go north to catch up with that gouge across I-50, I-59, I-39. That was the major discharge for all glacial meltwater in the last 135,000 years. Is that gouge? No, I mean this one runs north. There are like the Kankakee. Kankakee runs north, all for similar reasons, because glacial landscapes, these glacial moraines prevent water from going south through the Mississippi Valley. It's got to go north up to the Illinois River and then go back down. Same thing with the rock. It's got to go up to the rock and go back down. Yeah, I love doing this stuff. Other work in DeKalb, there was some work in the 60s by our group doing sand and gravel resource uh, assessments. There was work done in 1970 by Dave Gross, who, when I started in 2005, was still at the survey. Great guy, did a lot of work back then by hand, where they were mapping the geology, looked at aquifer conditions, sand and gravel resources. This is a mapping for planning program we had in the 70s and 80s, where we do county-based mapping. This is available on our website. There's an address there. It's an old 1970s pub, all done by hand. They didn't have the technology we did, but it was a fantastic resource. Mainly, they did that for siting landfills and construction, aggregates and construction. A little bit later, in 2004, another colleague of mine, Bob Baden, did an assessment of DeKalb County groundwater, mainly focused in the Troy Bedrock Valley, which is a bedrock valley that, if you strip off all the glacial stuff, there's a deeply incised, like 400-foot deep valley, similar to that gouge in the Kish now, that runs on the west part of DeKalb County. And they did an assessment of what's filling that thing. And he did a variety of cross sections where the gray stuff, the gray in those cross sections, this is a slice of the earth or vertically, to look at what the geology is vertically. And on those images on the right, the gray is all this limestone. And then in the middle of that, you see this gouge that's filled with yellows and blues and pinks. And those yellows are sand deposits that he mapped. The blues are clay deposits, and the pinks are clay deposits. So he was trying to understand what's filling that Troy Bedrock Valley. From that, they developed also some county-wide maps. Again, 2004, all by hand, with subsets of data. So it was a pretty good assessment of, on the left is what's the sand that's in the bottom of that Troy, what are higher sands that he calls the middle sands, that are some of those yellow units in these cross sections. And then the upper sands are some of the yellow units that are up in the pink, the youngest sands. So again, this is also a publication that is available. And on my slides, there is a link. And you can go search it too. On our website, just search DeKalb County. So again, a migration of what we understand in DeKalb County from 70, 2004, and then 2025, there's a statewide geologic map being reviewed and updated that will include DeKalb County, of course. Some of the cool things that most recently we've been working on, and colleagues of mine and colleagues at NIU, are looking at things called ice-walled lake plains. Anybody ever heard of an ice-walled lake plain? These are little landscape features that we started to find on the landscape in Illinois and in the upper Midwest once we started to get LiDAR data sets, laser scanning from airplanes of the land surface. And sorry, these are just paper titles, but one of the papers has actually described them as the DeKalb Mounds. So they've been named the DeKalb Mounds. Brandon Curry is one of the world's leading experts on ice-walled lake plains. If we look at where ice-walled lake plains are in Illinois, we'll talk about what they are. All the black dots on that smaller map are all these little features that pepper DeKalb County, and they pepper parts of the state. And what they are, these little pancake features that we see, and this is right in the middle of, this is the town of DeKalb, this is the landscape of DeKalb area, and you see these little pancakes. These are little uplands that are maybe 1 to 2 meters above the rest of the land surface, and they're flat as a pancake. And On the left is the land surface. On the right is the soil textures that we pull out of the soil data. And we can see that those pancakes are all one type of material. It's a very silty type